And we will now start with just some introductions of the ECHO team. Renee, would you mind introducing yourself again to the group?
Yep, my name is Renee Bolio Banks, Indigenous Cause, Shaganashimang. My English name is Renee Bolio Banks, Zagasqua Jamaica, Gandunjaba. I'm from Leech Lake Nation, Bigisi Nandu Dame, the Eagle Clan. Zibikwe Indigenous Cause, Indigo is my spirit name is River Woman. I work as an elder in residence at NACC, and I've been here for about 5 years, and I really enjoy my position, and my services are open to everybody. Just an FYI. Have a great meeting.
Language. And Dr. Robbie?
Language. My name is Kari Robbie. I'm a family practice and addiction medicine physician. I've been at NACC since 2012 and been doing work specifically with MAT since 2016. And I'm pleased to be here.
Good. Nikki?
My name is Nikki Jardina. I'm a public health nurse, and I've been at NACC off and on since 2017, and I work in infectious disease and a bit in MAT and on our harm reduction team.
And I'm Lindsay King Cooney. I'm the harm reduction coordinator. Also facilitate this ECHO program, work closely with the harm reduction team and outreach as well. So that's our team for Midwest Tribal ECHO. I'm just going to do a few announcements and then I'll hand it over to our speaker for today. Let me share my screen. All right, so welcome once again. We are the Midwest Tribal ECHO Opioid Use Disorder Education and Treatment Series. Today we have Ben Clark, who is from the University of Minnesota. He is a neuroscientist and the senior program manager of the University of Minnesota's medical discovery team on addiction. And he will be talking to us today about the neurobiology of SUD. If you're not familiar with our clinic, Native American Community Clinic is an FQHC. We were established in 2003 and we're located in the urban indigenous community, part of South Minneapolis on Franklin Avenue. And this is a list of all of our services that we provide. We are a full spectrum family practice clinic. Our website is down at the bottom if you'd like to read more about us. This is a list of current open positions at NACC. So again, there's our website at the bottom. If you go to the job section, you can read more about these listings. Some session guidelines, of course, no protected health information. We love to see your faces if you're willing and able to turn your camera on today. If you could let us know who you are in the chat, just let us know your name, title, and where you're from. And then we do invite you to ask questions in the chat. And we'll have a little time at the end for some discussion. Some announcements. So our next ECHO will be in October 2nd, and that is to be determined what the topic will be. This is a list of other ECHOs that we recommend that cover similar topics on opioid use disorder. If you'd like more information, you can always message me in the chat. And then we do offer continuing education credits for those who are eligible. You just will need to fill out the post-evaluation survey, which I will put the link in the chat and also email that out to folks at the end. And then finally, case presentations. My email address is down at the bottom. Feel free to email me or contact me in the chat if you have a case presentation to share. They always make for great discussion. And that is it for me. I will now stop sharing and welcome Dr. Clark.
Hello, everyone. Thanks for having me. I'm gonna turn my camera off in a minute when I share slides, just so some of the films will be able to play on some of these slides. But I really appreciate the opportunity to talk to you all. Let me share my slides here and we will get started. Can everybody see the slides okay? No?
Sorry, we actually could see it, but now we can't anymore.
Oh, okay.
But
All right, let
whatever
me
you
try.
just did worked, so,
Okay,
sorry.
okay,
Yeah, that looks great.
okay. All right, super. Thank you. All right, so as Lindsay mentioned, my name is Ben Clark, and I work with the medical discovery team on addiction at the University of Minnesota. And my background is as a neuroscientist. So I got my graduate work recording from neurons and trying to figure out how their activity changes, and the activity of the neuron then dictates how the neuron is acting in a circuit and what information is processed. Today, I'm going to be talking about some of what we're finding out about substance use disorders. And I just like to make a few disclosures right away. So we don't have a complete picture of the neurobiology of substance use disorders. We don't necessarily know why there's a subset of people that end up having addiction problems. And we also don't really have a firm grasp on everything that's happening through the life cycle of an addiction and how to treat it. However, we are learning a lot, and there's a lot of neuroscientists working on it, and we're starting to piece things together and get a little bit of a picture. So I think it's really important to share some of the things that we're learning, even though we can't provide a complete picture. And honestly, I couldn't provide a complete picture of much of anything in a 45-minute period in the neuroscience field. But some of the things that we're learning, I really think frame addiction and substance use disorders in a different way, in a different light. And it really kind of goes against any sort of outdated ideas about substance use disorders being a moral failing or pleasure-seeking type of problem. And so I want to talk to you about a couple of the things that we're finding out, and I'm going to provide this in some simplified versions, but I think that it will still be detailed enough to provide you with some helpful information to anybody who's either struggling with substance use disorder or has a loved one that's struggling with it. So the hope is that through these discussions, we can kind of decrease the amount of stigma that goes along with substance use disorder. Not only self-stigma, but public stigma for those that are creating our policies. So as an overview, I'm going to talk a little bit about the cycles of substance use disorders, then a little background on what the brain does and how. It's a very simplified version, so that we can talk a little bit about how drugs impact some of the areas of the brain. And then if there's time, we can talk a little bit about some of the ways that MDs have found that help for combating the impact of drugs, or we can even talk about some of the studies at the University of Minnesota currently. Okay, so to start out, cycles of substance use disorder. So this disorder has a clear cycle that happens over and over and over again. And even if a person doesn't develop an addiction problem or a substance use disorder, this cycle repeats over and over and over again. So the first stage is that binge intoxication phase, where a drug is used, and over time, as the cycle repeats over and over and over again, that might increase over time. Then after a short time, there's that hangover or that withdrawal negative effect, where there can be an increased depression, lower energy, and maybe increased anxiety. And then there's also that craving and planning part of it. And this may be delayed quite a bit from those first two events. But depending on where a person is with substance use disorder and how long this cycle has been repeating, this can start to occur shortly after that withdrawal phase. And that's the part where either there's an increased focus that's impulsive or an increased focus that actually becomes more compulsive in nature of how a person might be able to get the drug again. So like I said, this cycle happens over and over and over again. And for the subpopulation that do end up struggling with substance use disorder, this cycle starts to speed up, so that binge intoxication to the withdrawal and then to the craving and planning no longer is Friday to, say, Friday, or one holiday to the next holiday, but it starts to cycle in a way where it becomes more of a daily event. And as that is happening, each one of these phases is also changing a little bit. So we see that binge intoxication phase is switching from this initial amazing feeling of euphoria to the drug only making a person feel kind of a little bit good or a little bit better. And then lastly, as SUDs develop, it's more of an escape from feeling particularly bad. Then the withdrawal and negative effect, or that hangover phase, that starts to shift from just being like a headache, low energy, to lower excitement, to not being able to get excited about things that you used to be interested in, to an increased depression and increased anxiety. And then that green portion starts to shift from potentially looking forward to going to a party, for instance, to desiring the drug itself, to then being obsessed and compelled to actually seek out the drug, as opposed to, say, looking forward to an event where the drug might be there. And as this is happening, these things are slowly evolving. And like I said before, the cycle starts to go in an increased frequency. So that voluntary action is changing to an impulsive action, and then switching over to a more compulsive and habitual action as the motivations change in response to this ongoing cycle. This also ends up impacting the mood for people that develop substance use disorders. So in this slide here, that blue line is going to be depicting the initial average mood. And so this is something that I learned about in grad school, and as I was working as after grad school. And it's a behavioral assessment of like how this can actually change the mood of a person, this cycle. And I really thought it was insightful, and it actually made me even connect some dots in my head for some of my tendencies when I was an undergrad, for instance. So that blue line, if we think of that as the initial average mood that a person has, we naturally have ups and downs throughout days. So in this particular graph, I'm going to show with red arrows a use of any particular substance, basically a binge cycle beginning, and then we see that how it's impacting the mood. So initially, substance use will increase that particular mood. But as this cycle goes on and in more iterations, what we see is that initial increase in mood starts to decrease. So basically, you're not getting the same high out of that particular substance that was once available. And as it continues, the other thing that happens is that the low becomes a little bit lower. That recovery phase, the hangover phase, becomes a little bit lower. But in addition to that, the overall mood is actually shifting too, because you're not really rebounding to that initial average mood level. So as you can see here, that line is slowly making its way down and down and down. And then as it continues, we see even more decrease in the mood. We're not even rebounding to that initial average mood. The highs start to get very, very low in amplitude. And in general, whenever the drug is being used, we're not even reaching the levels that we used to be at, even when we were at our lowest point. And this is happening as that cycle is going over and over and over again. And for those that develop a substance use disorder, this can happen over the varying course of time. But in general, the other thing that we're seeing here is the frequency of the use would be increasing as well. So it's impacting the overall mood. And one of the initial questions that I think everybody struggles with is, okay, so if we are to assume that this is some sort of pleasure-seeking disorder, then why in the world would somebody continue to use this drug when it's actually decreasing their mood so drastically, and the pleasure that's gotten from that particular drug is no longer at nearly the same amplitude as it used to be? And some of the things that we're starting to figure out, I think, really start to shed light on what could be one of the reasons that we see that continued use despite negative consequences and a person actually wanting to stop using a particular drug. So the cycle, just to summarize, has this binge intoxication, followed by a hangover or a withdrawal, followed by craving and planning phase. And as this continues to go around and around and around, we see that this can actually change the overall behavior and mood and actions of some people, subset of people who end up developing a substance use disorder. So one of the really fascinating things about the field currently is we're finally starting to tease apart some of the areas of the brain that might actually be mediating some of the parts of that cycle. So that binge intoxication phase, that withdrawal phase, and that preoccupation phase. And this is just an image that shows some of the brain regions that we think are in charge of those particular phases. That's not to say that these are the only things active during that particular phase. The brain is a network, so all of these are working together. It's just to say that the area in blue, for instance, seems to be highly active, and the changes in that particular area seem to be highly correlated with the binge intoxication phase, for instance. That withdrawal or negative effect phase, where people start to become more and more depressed and more anxious after time of the substance use disorder developing, those things seem to be correlated with changes in the amygdala, for instance, and they seem to be go along with the idea that that area of the brain, while working with these other areas of the brain, might be a key factor in that particular part of this cycle. And so the next part, I want to talk a little bit about what the brain does so that we can then focus in on one of those particular circuits that I think is really key for like trying to understand what happens in the brain, and also in that it really helps to reframe what we might think about a substance use disorder or an addiction. So again, this is a very simplified model. It's going to get a little more complex than this slide, but in general, if we think about what the brain does, the brain is supposed to bring in information about our environment, and then we process it, and then we have some sort of an appropriate behavior. The term appropriate behavior here is really kind of meaning something that will help us survive, basically. So as we can move around in this world, we really need to know where to move to get the things we need, and where not to move if we're going to have something negative happen to us. And in this way, we can continue to survive and flourish as a species. So how do we do this with the brain? Well, the brain is made up of all sorts of cells that actually create what we can think of as a circuit. Different circuits that are doing different jobs. And this is kind of an abstract idea. At least I thought it was really abstract when I was learning about it. So one of the ways that I started to try to make sense of it was to think of a thermostat. So this is a really simple circuit that we're all pretty familiar with. It measures what the temperature is in a room. It relays that information to a second part of a circuit, and then that second part of a circuit will turn on a furnace or turn on an air conditioner, for example, so that it can make some sort of change to the environment. So that's a circuit measuring what's going on outside in the world and then making an action that will change how things are going to be going. So the brain does similar things, except we use neurons to do it. So this is a really simple example of one of the simplest circuits that we have in our body. And so I like to use the example of my kid's first birthday, because on my kid's first birthday, he had a cupcake in front of him with a candle. And we weren't thinking, and he reached out and grabbed at the candle and then burnt his hand and then recoiled right away. And we've all seen that type of a reaction many times. So what's happening in that instance? Well, in that instance, there's receptors at the finger that are going to be feeling that there's an increase in temperature that might be damaging that tissue. And then it's going to send information back into the spinal cord to relay it to another part of the circuit that's going to be able to recoil the arm. So a motor neuron that's going to be sending the message to the muscles to pull that arm back. So this is a very, very, very fast process, obviously, because we need to get that hand out of the fire right away. So we don't want it to go back to the brain and have a long committee meeting about what we're going to do next. It's very, very quick. Now, the other thing that's happening there, so this is an example of a circuit that's measuring something in the environment and then making an action. The other thing that's happening in this particular instance is information is also going up to the brain. And in the brain, it's being processed in a more deep manner. So we're also at that time learning about that particular experience. So B might be looking at that cupcake. He'll notice that the flame hurts, associate the flame with something bad, but then look around and see balloons and see everybody excited to see him. And those things will be positive parts of this entire experience. And the brain is kind of figuring out the positives and the negatives and how to associate that with future planning. So the next time we walk into a place with balloons, we're going to look out for the fire and not put our hand in it. Or the next time we see fire in just any environment, we won't put our hand right in it. So that's where that other learning part is happening, is in that brain. But it's all happening because of different circuits within the brain. And these circuits are really, really quite organized. So this is an actual film about different circuits within the brain. So these are neurons that in this case are in the hippocampus. But the reason I show you this is not only because I think it looks pretty cool, but also because it demonstrates that it's very, very organized. So there are these cell bodies, the dots, and then there's these filaments that are coming along outside, off of those cell bodies. And you can think of those as the wires that are kind of connecting to another part in the circuit. So the brain isn't just a bowl of spaghetti with a bunch of noodles all over the place. These circuits are actually very, very organized into actual geometric circuits that we can actually record from and figure out what types of behaviors they're going to be impacting. So that's happening throughout the brain. We have different areas that have these circuits that have particular jobs. And the brain is also very similar between people as far as just general shape and anatomy. So once when I was in human anatomy instructor, I would do dissections and show people the different brains and how they look and what different areas do. You might be surprised to find out that these seemingly random wrinkles within the brain are actually very, very, very much planned out, and you can see them in every human being that you would look at, and they have similar jobs for different parts of that particular structure. Not only that, we see that same area and that same structure even has the same job in other animals. So this is an idea that has evolved and been used over and over and over again. So one of the areas that I want to point out is this somatosensory cortex. So the arrow that goes to the right, showing that sensory cortex, it's an area within the brain that is actually activated when you feel something on your body. And different portions of that cortex are associated with different parts of the body. So when B reaches out and feels a burning on the hand, the area of the brain that's going to be activated is the area that is delineated by hand and fingers. So that part of the brain will be activated. So it's picking up information, relaying it to this area, and then that mapping of the body on this part of the brain is one of the things helping to make it so you can identify where something is touching you. Now, at the same time, if you have a thermostat where you can hold a lighter next to it and all of a sudden make it think the room is really hot and turn on an air conditioner, at the same time, you can bypass certain parts of this circuit too. So if you were to stimulate the brain at that region that says hand here, a person would actually feel like there's something on their hand. However, that's not actually happening, and that's false information about what the environment is. But you would still feel that something was on there because that part of the circuit that's supposed to relay this information about where things are touching you is being activated. One last thing about these circuits and how these circuits communicate within the brain to get from one part of the wire to the next part of the wire, rather than just using a switch, what the brain uses is it uses chemicals. So things like dopamine, serotonin, those are some of the neurotransmitters or neuromodulators that you've probably heard about. And those are certain chemicals that one particular part of that circuit will release to activate the second part of that circuit. And we're going to talk a little bit more about dopamine because that one is one that's been really popular in the general public and especially associated with substance use disorders. So to get that message to be sent to the next part of a circuit, there are two things that happen. You release some of that neurotransmitter or that dopamine, and then you have something on the next part of the circuit that will be able to collect and interact with that dopamine and make a change on the next part of the circuit. So in summary, the brain is taking in information about our environment and hopefully having us respond in a way that will be beneficial to our survival. And the brain is organized in circuits that are going to have specific jobs. So like that sensory cortex that we talked about. And in these particular areas, these circuits are always going to be doing the same type of thing, regardless of which person that we're going to be looking at. So that's very systematic. And the goal is that we will learn things that will be beneficial for our survival, important things where we can go get food, social interaction, sex, water, friendly interactions with people, things like that, and avoid things that might be dangerous for us. So how do drugs interact with this then? And why am I talking so much about these circuits that have to do with a candle and burning your fingers when you're small? So let's look at a different circuit in this portion of the talk. So right now I want to look at the circuit that is using dopamine. So we hear a lot about dopamine being this pleasure molecule, and it's associated with doing something that's pleasurable. What we're actually finding out is that dopamine is not actually mediating this. It doesn't bring information about something that happened that's pleasurable. Instead, it's bringing something a little bit more nuanced than that. It's bringing information about a reward and something that's motivating you to do something again. Something happened that was important for what would normally be associated with your survival. So how do we think about that? How do we know about that? So one of the things that we do is we look at the brain and we measure the activity of the brain when a person or an animal is getting a natural reward, for instance. And we see that this area, this VTA area that you see in the picture on the right, is activating this NACC area, the NACC area, nucleus accumbens, that you see on that picture. So there's information that's being transferred by releasing dopamine in that VTA to the nucleus accumbens. And the information that we think is being actually sent there is the information that something that just happened was rewarding and is important for survival. And it should be, you should try to do it again in instances where that's available. So if we're learning about that, what we're going to see is that that dopamine is mediating that signal, and it's not mediating a pleasure signal. So we can also measure that dopamine that's being released at that particular area where one area, that VTA, is synapsing on the nucleus accumbens. And what do we see when we measure that? So here is some data that shows the response after a natural reward like food. So in this case, there's always a trickle of dopamine that's being released into that area. And we've named that 100 here. So we've normalized it to 100. And then at the inflection point here where it starts to go up, that's when a food reward was given. So you see that the amount of dopamine that's being released increased from 100 to 150%. So it increased quite a bit. And that's to delineate this unexpected reward of getting a food item. a natural reward, and that's going to help us to learn, okay, this is a good thing and this is where we got it. We need to remember this so we know where to find it again. So can we do the same thing but provide a non-natural reward like a substance that is commonly abused? Well, we can. And so we've done that with amphetamine. So in the same subject, looking at the amount of dopamine that's released, if you look at the axes, we see that all of a sudden we're going from 100 to 1,000. So this is a enormous blast of dopamine that's occurring within the system when this non-natural reward is given. So this reward is coming from something that isn't normally found in nature. In this particular case, it's amphetamine developed in a lab. In other cases, it might be alcohol that's purified or an opioid that's purified from the plant. But in any of these cases, it's a non-natural reward, something that we wouldn't normally be coming into contact with. And so it's bypassing that normal system and going straight to the area where we're getting that reward signal and blowing it out of the water. So in this scenario where I talked about how if you stimulate where the hand is on the cortex, you will feel something on that person's hand, even though there's nothing on the hand. It's a false bit of information about the environment. Well, in some ways, that's exactly what this is. This is false information about the environment because it's bypassed all the other brain areas, especially with amphetamine, and it's just stimulated that region, that particular place in the brain to really boost the amount of dopamine that's being released in this particular case. And it's something that system is going to have to change the entire way it's going to be functioning because it's not used to that level of dopamine. So if you want to think about something that is extremely loud, well, here, let me talk briefly about this. So one of the things that we know is that, so drugs have different effects on a person. They have different effects on how a person feels. And that's because they're actually interacting with multiple areas within the brain. But one of the things that we see, and this is a really complicated slide, but it's just to show that all of these complicated interactions also lead to an increase in the dopamine that's being released from that VTA area to the nucleus accumbens, an increase in that reward signal, that motivation circuit. And it's blowing that part of it out of the water. And so this is saying this particular thing that just happened was extremely important and is not only just kind of a good thing to do, but it's way more important than these other things, these other natural rewards. And we should think about it and try and do it again if possible. The other thing to think about for this particular region in the brain is it's located in an area, the synapses that we're talking about, it's located in an area that's more of an undercurrent of a thought as opposed to just a fully conscious thought. So some of the areas of the brain are definitely mediating planning, where we're actually thinking about specific things and we're engaged in voluntary thought process. Where that VTA is here, this is a part of the brain that's actually running things like our breathing rate, it's running our heart rate, these things that are more involuntary or subconscious things that we're expecting the body to just kind of keep doing so we can keep going, walking around and doing what we want to do. And so one important thing to also notice here is that this undercurrent of information from the VTA to the nucleus accumbens, it's actually almost more of a subconscious signal than a planning out type of signal. Now we can actually use our planning out part of the brain to try and tamp that down a little bit, but it's important to realize that that part is almost more of a subconscious message that's being sent over and over and over again. How am I doing on time here?
We are at 12:40, so 20 minutes to 1.
Okay.
You're doing good.
So to sum up what I was just talking about there, so I'm talking about only one particular circuit. There are many other circuits that are involved in using drugs and the development of substance use disorders. But this one particular circuit, this reward motivation circuit, is definitely one of the ones that's impacted. And once that cycle continues to go on over and over and over again with these extremely unnatural signals that are happening, then that particular circuit is going to start to adapt. And it's going to start to dampen the way we might think of, say, a natural stimulus, because now we're looking for that really, really, really large volume stimulus from the unnatural rewards. And this is not mediating the pleasure signal. That's done by endorphins, a separate system within the brain. This dopamine signal is more of an unconscious message, and it's saying whatever happened is really important for your survival. So, for instance, that food we had, that water we had, those healthy relationships that we had, the social engagement that we had, a sexual experience that we had, all of those things are important for our survival and the survival of the species. And now we've got this new thing that was just put on board, and that is also activating this circuit and telling us the same, giving us the same message. This thing that happened was really important for survival. So I want to take a second here to take any questions on that portion. I know that's a lot to take in, and there's some concepts that are different from what you might have heard in the general public and on the news. But are there any general questions about that? No? Okay, so what's happening within the brain as these changes are going on, these changes in structure? So one of the things that is happening is the receptors that are picking up that dopamine signal are going to start to change a little bit. So they're going to start to switch from one kind of receptor to another kind of receptor, and they're going to actually start to go away a little bit. And one of the things that we can see in human studies is the evidence shows that there's going to be a decrease in the availability of these dopamine receptors. So a decrease in the dopamine receptors for somebody who has a particularly difficult time with substance use disorder. Now, over the course of time, if that person is in recovery and they're able to avoid any relapses, we can see that will increase again. In the similar way, we see that the actual size of certain areas of the brain will increase over a time of recovery as well. So there are certain things that we can do to combat the impact of what drugs have already done to the brain. So the brain can become the brain changes, it's malleable, it's not a thermostat. We learn things. So that's a great thing in that not only can it transition to this state where we have developed a substance use disorder, but it's also still has that plasticity and that ability to be able to start to move back to a more healthy state. And so some of the things that some of the medical physicians that I work with, some of my colleagues who specialize with addiction have been talking with their patients about is you can actually do a lot that are just behavioral efforts to try and make that brain heal up. So for improving attention, try to doing word puzzles or memory games, journaling daily. Decisions and controlling urges can be helped out by doing mindfulness exercises, breathing deeply, just trying to figure out how to connect your ability to actually impact those craving or those urges. There are those green circuits that I showed a long time ago on the slide that can actually come into play here and try to start dampening these unconscious craving messages that are partially happening from this reward circuit. And we have some really interesting studies that have even shown that in some people who are successful with their recovery, when we compare them to those that have relapsed and had a difficult time and look at the strength of connectivity between, say, that green area and the blue area, what we see is that those were successful in their recovery actually have a stronger connection between those areas. And interestingly enough, what we also see is those that never developed a substance use disorder have a connectivity that's more similar to those that ended up relapsing than it is to those who have been successful with their recovery. So over time, what that looks like is that there's something that's being done during your recovery where you're actually strengthening that particular message that's being sent beyond that of what, say, a normal person would have. So those that have been successful with that recovery have higher connections between these areas. And one of the things that we're trying to figure out now is how can we even boost this further? So we know that some of these things like healthy relationships and doing some of these activities, almost like physical therapy activities, can help with this. And now we're trying to figure out ways that in addition to that, we might even be able to provide a boost that would make that system more susceptible to becoming stronger, kind of like if you would think of your brain on steroids almost. So stimulations that would lead in conjunction with these to actually building that up even further. So in summary, so substance use, it happens with this cycle. It's this binge intoxication, withdrawal, craving, and planning, these three parts of this particular cycle, and they cause long-term changes in behavior, mood, and motivation. They also, since they're making changes in behavior, mood, and motivation, they're also making changes within the brain. And so one of the things they're doing is they're impacting that reward motivation circuit that uses dopamine as its signal. And so they're basically hijacking that area of the brain with a false signal about what's going on in the environment and basically telling you that something that just happened was really crucial for survival and you should try to do it again and again. And this is happening at the same time as we're seeing the behavioral transition from that impulsive use to obsessive or compulsive use, and that increase in frequency of going through that whole three-step phase, that three-step cycle. So again, the message of the dopamine circuit isn't pleasure, it's not reward. And I think that's really key because it says that there's something happening here that is completely disconnected with that old worn out theory that those who have problems with addiction or substance use are just thrill seekers or are just looking to have a quick fix, a quick pleasurable outcome. That's not really what's being mediated by this dopamine signal. And instead, it's more of an incessant underlying current that's giving this message that something that about that particular substance is really important for survival. And that is also happening during this phase where there's a transition from impulsive to compulsive and obsessive use. Now, there's other things that are happening in the brain at the same time that this is happening. So I'm not saying that this is the circuit that mediates the entire disorder that we associate with substance use. I'm just saying that this is one of the key circuits that we've learned about that is definitely changing due to that repetition of that cycle and is impacting these behaviors that lead to what we would call substance use, even though there are negative consequences associated with it. And then lastly, really importantly, so just as the brain can change in response to these substances of abuse, it can also start to change back to a more healthy form if we go in the other direction. So if we start to do things to exercise those circuits within the brain, if we start to have more healthy relationships, if we start to have a better diet even and better sleep, all of those things can really, really help to strengthen those particular circuits. And we see it with those that are successful with their recovery, we see an increase in the gray matter size of the gray matter within that brain, indicating that the brain is changing again and coming back to more of a healthy state. And that can be helped along by journaling, physical exercise, mindfulness. What we're doing is we're trying to actually find out ways that we might even strengthen that change, strengthen those changes within the circuits that we've identified so that basically we can help those out as they start to go into recovery. Because we know that if somebody's successful in recovery over that first really difficult 2 weeks, 2 month, 1 to 2 week phase is very difficult. Then we see another point in time where up to like 3 months is still very difficult. And then, but once you hit a 3-month mark and then you hit a year mark, those that are successful with the recovery that long out seem to have a much easier time continuing on with that success. So we're hoping to try and find ways that we can increase the activity of these circuits, particularly at those initial phases where somebody's reaching out for treatment or recovery, to really try and help with those initial cravings. So substance use disorder occurs because of changes in the brain and the circuits that mediate behavior. It's not a moral failing. The brain can be changed, it's malleable, and it changes to the conditions that are external and internal to us and that we impose on it. So we can actually begin to actually make it healthier again. So there's always an opportunity to start rewiring and changing outlooks and behaviors, no matter how far down the path of a substance use disorder a person may have come. So are there any particular questions? Once again, I'm from the University of Minnesota's Medical Discovery Team on Addiction. We're trying to do outreach to the community. And not only do I go out to encampments and provide harm reduction supplies, but I'm also trying to go out to the community and provide some of this information about what we're discovering in our scientific research. So if you know anybody who would be interested in this particular talk or anything similar to it, please feel free to send them my contact information. Any questions in particular?
Thank you, and I'll definitely send out your contact information, Ben. There's a few comments and questions from Ren. Ren, do you want to unmute and ask those? And Jeff, I see your hand up too. I can go in here and
Maybe just let Jeff ask his question
Okay.
since he's here.
Jeff, feel free to unmute.
Yes, thank you, Dr. Clark. Jeff Mitchum here in South. Just a little curiosity on the dopamine release within the electric circuit of the brain. Is that noticeable on EEG brain mapping? And if so, would you find it more beneficial for neurostimulation therapy or neurofeedback training or neuro rehab?
So the particular circuit that we're talking about is more deep within the brain. So an EEG wouldn't be able to pick up that particular signal and distinguish it from other signals, electrical signals that were going on at that particular time.
Okay.
As for the stimulation question, we are seeing that non-invasive stimulation, so stimulation, either magnetic stimulation or direct current stimulation, that is done over through the skull, and done along with these particular activities that activate these particular circuits, has been helpful in helping people decrease their craving and be more successful with their recovery journey. So we are seeing that is something that can be effective, and we're trying to figure out the best ways of doing that. So the idea is that, so in order for a change to happen within a circuit that will be long lasting, it needs to be kind of a strong signal that's happening over and over again, kind of like the repetition that one might go through to learn a new skill or learn a set of facts. So one of the things that we're trying to do is figure out activities, and one of the researchers that my friend at the university is actually using almost like a video game type activity that a person will undergo that we know will activate this part of the brain, and then give as light a stimulation as we can possibly give, but enough that will boost that particular signal up and help strengthen the connection to help with recovery. The amount of stimulation, this isn't this is not like neurostimulation like you might see in the old movies where it's going to lead to convulsions and things like that. This is very mild and directed, and we're really, the goal is to have it be as mild as can be and still be effectual. The neurofeedback has been more difficult. We've tried looking at those neurofeedback studies and haven't had as much success, but we're still working on trying to use that method as well.
Okay, thank you so much.
Yep. Ren, was that the other person that had a question?
Hey, let's see. The question, the most important question I had in chat was about the like false survival messages from the dopamine circuit, and wondering about like instances where that use of the substance might like be helpful for someone's survival. I'm thinking specifically of like multiply marginalized, unhoused folks using, say, stimulants in order to be able to like survive through the night if they don't have a place to sleep. There's obviously like a potential physical consequence there. But I'm guessing, I'm thinking about what that would mean for that circuit. Like it's the same input with potential negative consequence, but is potentially helping survival.
So, okay, a couple thoughts on that one. So we've done a lot, well, not me personally, but over the decades, there's been a lot of research to look at how, say, a stimulant would be affecting a person in general, like just general things like heart rate or functionality like memory and ability to relate stories and things like that. We haven't seen anything that would say help somebody get through a cold night with a stimulant like that. But we do actually use, and many of you probably know this, things that are similar to amphetamines for instance, like ADHD. And we're trying to figure out like how that would potentially be helpful in one population, but not helpful in another population. Part of the answer might be, well, definitely a huge part of the answer is this, despite that general organization of the brain being similar from one person to the other, there is a lot of variability. Obviously, we're all different people and we have different susceptibilities to depression, anxiety, substance use disorder, schizophrenia, all sorts of different mental disorders. But one of the things that makes dopamine tricky is that dopamine release is going to interact with two types of receptors, a D1 receptor and a D2 receptor. A bunch of dopamine will lead to more of the activation of a D1 receptor than the D2 receptor. This is something that we see actually changing as somebody is developing a substance use disorder. But the actual way that this particular circuit might integrate with other circuits, and just the way that these receptors might, the population of these receptors might be expressed on a particular person's circuit, might change the way that, say, Ritalin might be effective or Adderall might be effective to somebody with ADHD, whereas somebody who has a susceptibility to addiction and addictive personalities, it might end up being something that would lead to, say, a substance use disorder. Did that answer the question?
Sort of. I would love to connect more in the future, possibly.
I can definitely, I know you had your email on the last slide. I can put that into the chat and send that out to everybody. There's a few other questions, but I want to be mindful of time. We have about 1 minute until
I
1
can
o'clock.
stay on, and I can stay on later if anybody has additional questions.
Okay. I know, Chris, you've had your hand up. Did you want to unmute?
Yeah, hi, I'm Chris Mattson. I was an addiction medicine student with Sheila Specker and did my fellowship.
Oh, Sheila, I know Sheila. I'm on a project with her actually, looking at Recovery Capital.
Yeah, I love her. She's one of
it's
my
great.
main mentors in my life. But anyway, but I'm sort of I say kind of in quotes retired now, but of course here I am. So I just have a more of a comment, and I find this discussion about do opiates and other drugs cause pleasure, or do they cause this sense of repeat it, repeat it, repeat it, you need it for your life? And I think it's the same thing. I think that it's very difficult to tease those things out. I mean, it may be that you need it for your life, but the way that you need it is by this constant messaging of that is pleasurable. And I did some research at the U of M, probably 10 or 15 years ago. And I asked patients, tell me how you feel when you take your drug of choice. It was usually heroin. And they always said things like, it's very pleasurable. It's extraordinarily, I met God. Now I know why I was born. Now I have a reason to live. And it was, very fundamentally, deeply to my life pleasurable. So I think that these two things are inextricably twisted together. That's just
I've heard that thought before, but if you think about liking and wanting, those things are very different actually. And you can tease those apart as being really two different types of behavior. And one of the ways that they've actually done that is looking at responses to something sweet and responses to something bitter, for instance. So the response to something sweet is a pleasurable feeling, and that usually is associated with, say, endorphin release, whereas it's not associated with dopamine release. And we can see that by inhibiting the dopamine release, and we still see that pleasure signal. And conversely, we can do the opposite type of thing, where we can actually tease those two things apart to see that what the arm of that liking versus the arm of that wanting or that motivation arm. And I think one of the reasons that it is such a huge difference and an important difference is if you are going to go in and then try to start helping, say, somebody who has immense craving, and you just target that endorphin signal or that liking pleasure signal, you're actually not going to help the craving. So if we don't tease apart the different parts of what's actually mediating this behavior, then I think that we run into problems when we're going to be trying to actually figure out ways to help somebody out that has it. But I can forward you some really interesting papers about teasing apart that liking and wanting. But we might find them really fascinating if you want to send your email my way.
Thank you.
Ben, it looks like Kate has a couple of questions. So what is all included in your harm reduction outreach? And then she also asked, do you happen to have a slide comparing percentage of basal dopamine release in food, amphetamines, fentanyl, just so I might be able to use as a visual for patients, family, non-medical people?
I don't have a slide that shows the fentanyl. For my outreach at harm reduction, I partner with Twin Cities Recovery Project. So typically so every Tuesday and every Friday, Twin Cities Recovery Project goes out to encampments and provides food, water, and then harm reduction supplies like cookers, cotton, clean needles, alcohol wipes, bandages, sometimes bubbles and straight pipes, and then pamphlets on how they can get into treatment or into recovery. And we meet with hopefully the same groups week after week after week, but when the encampments get closed, then it becomes harder to find these individuals because it usually takes several appearances to gain trust with anybody where they feel comfortable enough actually asking us about getting into treatment or recovery. But that's my primary the group that I do harm reduction with, and that's on Tuesdays and Fridays.
Hi, this is Kate. I just wanted to say thank you. I'm a PA. I work for the Yakima Nation, and I just wanted to thank you for your verbiage and how you contextualize substance use disorder into like an actual physiologic process. And I think that takes like the stigma and the sort of negative connotation away from it. And I think it starts with us as providers, really changing how we speak of like the neurobiology. And I wanted to thank you because it makes it more accessible, I think, to our community members when we sort of reframe what's going on in the body. So I really do appreciate it.
Thanks a lot. That's one of my big goals, is actually trying to help break down that stigma. And again, I can't stress enough, this is a simplified version of what story about what we know about one particular circuit. There are, as Chris knows, many other circuits that are involved, but I think this is a really, really crucial circuit to kind of open the door to help break down that stigma, just to open somebody's mind to some of these other messages that are being sent maybe more subconsciously in somebody with a substance use disorder.
Looks like just a couple more questions if you have a little bit more time. Jolinda Anderson said, as we start to use genetic testing in relation to medication metabolism, are there thoughts that this could help us understand why some people have more susceptibility to addiction?
I think we're further away from that than we are from other things. So like some of the things that we do can correlate fairly easy, at this particular time, is that those who might suffer from depression or general anxiety disorder or have adverse childhood events or trauma, all of those experiences or other disorders that we see tend to overlap with substance use disorder. So that might be a little bit more helpful to take under consideration at this point in time. The difficult part with so many of these mental disorders is that it's not like Huntington's. Huntington's was really exciting because it was one protein that was just totally screwed up, and we could really, really, really do a lot to treat it by fixing that one thing. But all these other disorders that we see, there's a lot of circuits that are involved, and it's not just one gene. It's, a whole life of experiences, and one person might be more susceptible based on their genetics, but there's really, really nothing that we know right now where we can say this person is going to be developing a substance use disorder.
All right, well, thank you. It looks like a lot of thank yous, and I think I'll make sure to send out the slides. This will be recorded. We do have a YouTube channel that all of our sessions are recorded, so this should be available by the end of the day today. And when I email all this information, I'll send you the link directly to that YouTube channel. So yes, this is recorded. And I think we got to most of the questions. I'll definitely review. And if there are any that we missed, we'll make sure to get those to Ben. So thank you everybody for being here and staying a little bit later. Thank you to our speaker, Ben. We really appreciate it. It was a great talk.
Thanks a lot, everyone.
Indeed. Thank you.
Have a great day. Thank you.
Was there an evaluation link?
Yeah, it's in the chat, but I will,
No, it's okay. If it's in the chat, I'll find it. I
okay,
keep
great.
scrolling back and forth. Thank you so much. I found it. Okay.
Okay, got it. Great.
Thank you. Have a good day.
Bye-bye.
Bye-bye.
Bye. Thank you, everyone.